Okay, let's have a look at this past paper question. It's grade 10, November 2018, from those national exemplar papers. It says a group of learners prepare a 0.25 mole per cubic decimeter solution of sodium carbonate. Okay, so this moles per cubic decimeter is concentration of sodium carbonate by dissolving a 14.2 gram sample, so this is mass, of hydrated sodium carbonate to Na2CO3.XH2O in 200 cubic centimeters of water. So that would be a volume. Okay. It says to explain the meaning of the term hydrated. Well, this is a hydrated salt because this XH2O, see the little dot here? The XH2O is bound into the crystal lattice. So it means that all of those little sodium carbonate ions are surrounded by water in the crystal lattice. Okay, so hydrated means they have water, okay, in the crystal lattice. Remember, all ionic substances form crystal lattices of slightly different shapes, like a little jungle gym of ions. Then it says to you, write down a balanced chemical equation to show how the sodium carbonate dissociates in water. So if you are already ionic, like sodium carbonate is, you will dissociate in water, which means the sodium carbonate is going to split into its ions. So initially this sodium carbonate will be solid, and when you add water, it will split into its ions, and it will have sodium ions and carbonate ions. Okay, and so because they are now in solution, we will call them AQ for aqueous. It was previously S for solid. Okay, but what you need to pay attention to is that this subscript becomes the coefficient on this side. There are two sodium ions with a single charge, and this polyatomic carbonate ion, which you should know the polyatomic ions and their charges. This is the carbonate ion CO3 2-. If you forget any of the charges, your answer is wrong and you will not be marked correct. Now it says to you, learners then take 10 cubic centimeters of the prepared solution and allow it to react completely with 5 cubic centimeters of the dilute hydrochloric acid according to the following balanced chemical equation. Sodium carbonate, now if there's no coefficient here, you know it is a 1. Sodium carbonate plus 2 hydrochloric acid goes to 2 sodium chloride plus water plus carbon dioxide. So this is a kind of acid-base reaction. Remember, the general reaction for this is an acid plus a base goes to a salt, water, and carbon dioxide. Whoops, sorry, what nonsense am I writing? This is not a base. This is an acid. It is a base, but it's this kind of a base. It's an acid plus a metal carbonate. Sorry. This is a metal. Sodium is a metal, and this is the carbonate ion. So an acid plus a metal carbonate goes to a salt, water, and carbon dioxide gas. Okay, define the term 1 mole of a substance. So here's the definition over here. The amount of a substance having the same number of particles as there are atoms in 12 grams of carbon-12. And remember this, there are 6.02 times 10 to the 23 atoms in 12 grams of carbon-12, Avogadro's number. So this is a mole contains the same number of particles as there are atoms in 12 grams of carbon-12. It says what type of chemical reaction is represented by the chemical equation above. It is an acid-base reaction, okay, because hydrochloric acid is an acid and it's reacting with that metal carbonate, which is acting as a base. You cannot have an acid-only reaction. You always have to have an acid-base reaction. This one also has another identity because of this carbon dioxide. It is also gas forming, so they should accept both answers, but the answer they're mostly looking for is the acid-base. Now it says to you, calculate the number of moles of hydrochloric acid in 5 cubic centimeters, this is a volume, of hydrochloric acid if its concentration is 1 mole per cubic decimeter. So this is concentration, and they are asking you for what? This here is what we are asked for, the number of moles, and this is always given the symbol N. So we are looking for N. So which formula links N, C, and V? It's the concentration. So C, okay, and it is always best that you write what you are looking for. We are looking for the concentration of hydrochloric acid is N over V. So label your calculation, because sometimes you're going to use like N equals M over M a million times. Your examiner wants to know which one you are doing. So now that we've written the formula correctly from our data sheet, we can substitute. The concentration is 1. We are looking for N. And now we sit with a problem with this volume. In all of these formulas, the volume must be measured in cubic decimeters. So 1,000 cubic centimeters equals 1 cubic decimeter. You have to know this conversion. So this is going to be 5 times 10 to the negative 3, which is the same as 0,005. Either way, 5 over 1,000, it's the same thing, or 5 times 10 to the negative 3. These are all the same way of writing the same number. So if you do a little bit of cross multiplication across the equal sign there, you will end up with N equals 5 times 10 to the negative 3, or 0,005. And then what is the unit of this? The unit is moles. They were asking you the number of moles, so make sure you put the answer as moles. Okay. Now it says to you, calculate the mass, which is M, of sodium chloride formed in the reaction in question 7.3. Now, I found this a little bit confusing because up here you've got all of this information about the sodium carbonate, and technically you could probably do it with this information about the sodium carbonate, and they don't specifically say to you that we use this particular hydrochloric acid. But given that they've just asked you here to calculate the number of moles of hydrochloric acid, this is probably what you're supposed to use. Usually they're a bit more explicit in the question, and they say calculate the mass of sodium chloride formed in the reaction in question 7.3 if this hydrochloric acid is used, yeah? So, but they didn't say that, but we're going to assume that. So we're going to assume that we know this hydrochloric acid, we know the moles of the hydrochloric acid, and we are trying to find something about the sodium chloride, okay? So they asked you to find the mass of the sodium chloride, and we know something about the hydrochloric acid. So now you can't be comparing mass and moles. You always have to compare moles and moles. So in a balanced chemical equation, if you know one thing in the equation, you can find anything else using the mole ratio. So the first thing you have to do for 7.4 is to find the mole ratio. So what do we know? What are we given? Hydrochloric acid. What are we looking for? We are looking for sodium chloride. So you take the coefficients from the balanced equation. 2 hydrochloric acid forms 2 sodium chloride. So 2 to 2 is the same as a ratio of 1:1. So we had in that 5 cubic centimeters, we had 0,05 moles of hydrochloric acid. And so because the ratio is the same, we will form exactly the same number of moles of sodium chloride. So you have to make a mole-mole comparison, and this step, the mole ratio, is going to earn you a mark. If you don't show it, you will lose the mark. You always have to show the examiner what you are thinking. So what did it ask you? It asked you to find the mass, which is M. So now we need a formula linking N and M. So the formula that links N and M, it's going to be N, the number of moles of sodium chloride, is equal to the mass of sodium chloride over the molar mass of sodium chloride. So before you start this calculation, what you can do is you can say, what is the mass of sodium chloride, the molar mass of sodium chloride? It's going to be, you go to your periodic table and look, 23 for the sodium and 35.5 for the chlorine. So that is 58.5 grams per mole from the periodic table. And then we just come to our formula here, and we say 0,005 equals M, the mass we're looking for, the mass in grams, over the molar mass, big M, 58.5. And if you put that number into your calculator and you press all the right buttons, you get the mass of sodium chloride is going to be equal to 0.2925, but you need to actually round that off to 2 decimal places or 3 significant figures, if that is better for you, depending if you've got a really, really small answer. So the mass of sodium chloride is going to be 0.29 grams. Make sure you put the grams, otherwise your answer is wrong.